Greetings everyone, we will continue our discussion on programming for problem solving using C. In the previous sessions we have started about pointers and what you can do with those pointers. In this session we will be looking about some more related topics with pointers, that is memory allocation and dynamic memory allocation. In the initial parts we will be looking about what is memory allocation and what is static memory allocation and dynamic memory allocation, and what is the difference between the static memory allocation and dynamic memory allocation. Then we will be looking about how you can perform the dynamic memory allocation in C language. First, what is memory allocation? Memory allocation in programming is very important for storing values when you assign them to a variable. So I think you remember whenever you declare your values in your program, that is whenever you declare a value in the program, so the declaration makes a memory location be assigned to A. So based upon the type of declaration you are doing, memory locations will be assigned for your particular variable A. So these memory locations which you are assigned, which we are assigning in your program memory, we will be calling it as memory allocation. This memory allocation is very important because most of the information what you are trying to manipulate in your programs will be present in variables like this. So the allocation is done either before or at the time of program execution. So the memory allocation can be done during the execution of the program or before the execution of the program. Most of the programs which you are writing until now, in that memory will be assigned before the program execution. Okay, so when you perform this particular thing, that is so when the memory is assigned before the program execution, we will be calling it as a static memory allocation. Okay, when it is done during the program execution, we will be calling it as a dynamic memory allocation. So the static memory allocation will be done during the compilation time, and the dynamic memory allocation will be done during the runtime. Okay, so based upon when you are performing or when you are allocating memory to your variables, the particular types of memory location we have. So the memory location can be done during the execution of time. When during the execution of time, we will be calling it as a dynamic memory allocation, or before the execution, we will be calling it as static memory allocation. So the allocation can be done either before or after at the time of program execution. This will eventually allocate memory for your variables declared by a programmer via the compiler. So whatever may be the declarations you have done in your program, all those particular memory variables will be assigned memory or allocated memory during the compilation or during the execution of the time. Okay, or during the execution time of your program. To better understand how your memory will be assigned, this is a conceptual view of your memory for a program. So this is a program memory in which it will be present. So every program will be having the basic program instructions. Okay, every program will be having the basic program instructions. This is program memory. So each and every program will be provided this amount of memory for this declaration of your variables and everything. So when you write the instructions for the program, that instructions will be stored in one space called as the instruction space or the program instruction. Okay, the instructions will be stored in one particular place, and the global variables which you declare in your program will be having a separate location, and the static variables which you declare will be having this particular location, that is local variables. So the static variables will be having a separate location. All these three parts will be stored in the permanent storage area of your memory. All the three parts, that is your global variables, program instructions, along with that the static variables will be stored in the permanent storage area of your program memory. And the declarations you do, the local variables will be having a separate space called as the stack. Okay, the stack and the global variables, this will be having a fixed size. Why? Because so the permanent storage area, that is the instructions you write, the global variables you declare, the static variables you declare, and the local variables you declare will be decided before the compilation itself. So during the compilation, all this memory will be assigned for your program. So while the compilation is happening, so your program instructions will be having its space, the global variables will be having its space, the static variables also will be having its space, and the local variables will be provided the space in a stack. Okay, all these things will be done during the compilation time. And there is one free memory which you haven't been using so far. This free memory will be present in one heap, one unit called as heap. This heap is a dynamic memory, where you will be providing memory for your dynamic memory allocation. And this is not a fixed memory. This will keep changing during the execution of your program. Okay, so this is a fixed memories. Okay, these local variables, global variables, the permanent area storage will be a fixed memories before the compilation. Once after the compilation, this doesn't change. During the execution of the program, the free memory changes based upon your allocation and deallocation of your memory. The heap size will increase and decrease. So this is a program memory. So the program memory will be divided into these parts. It will be divided into the permanent area storage, the stack, and the heap. In the permanent area storage, we will be storing your static variable, programming instructions, and your global variables. In the stack, we will be storing your local variable declarations, and in the heap, we will be having a free memory. This free memory can be used for your dynamic memory allocation. The free memory is the only memory which will not be a fixed memory. It will keep changing based upon the allocation and deallocation you do during the dynamic memory allocation. Okay. So the global variables, static variables, and the programming instructions get their memory in the permanent storage area, whereas the local variables are stored in your memory area called as stack, as I already told you. Next, the memory space between these two regions, that is the permanent storage and your stack, the memory between that particular things will be calling it as the free memory or the heap area. This region is used for dynamic memory allocation during the execution of the program. Okay, the size of the heap keeps changing. So the size of the heap, whatever you are having, will keep changing during the execution of your memory. At a particular instance, your heap might be very small. So during the allocation, it might become big, and during deallocation, that is, once after using that memory, you can release that memory, and again that memory can be reused again and again for different purposes in the execution of your program. So this particular heap memory can keep changing during the execution of the program. It might reduce and it might expand based upon the consequences of the program execution. But these three memories that will be fixed memories, that is the stack and the permanent area storage, will be fixed during the compilation itself. Once after compilation, so you can assign the memory only from your heap memory. Okay, so if you are allocating the memory before the during the compilation of the program, before the execution, we will be calling it as the static memory. And if you are assigning memory during the execution of the program, we will be calling it as dynamic memory. That dynamic memory will be coming from your heap. Okay, so the dynamic memory allocation will be done by using the heap structure. So you need to understand the basic difference between the static memory allocation and dynamic memory allocation. So as I told you, static memory allocation is the memory allocation which you do before the program execution. Dynamic memory allocation is the one which you do during the program execution. While the program is executing, you can allocate the memory and deallocate the memory. Apart from that one, so the allocation is done before the program execution, the allocation is done during the program execution. So the first important point is, in this case, during the static memory allocation, the variables will get allocated permanently. Okay, whatever the memory which you are allocating, for example, you are declaring variables. So far you have been declaring variables like this. The variables will get the allocation of the memory, that is 4 bytes and 4 bytes. those 8 bytes of memory will be allocated permanently for A and B. Okay, so in this case, in dynamic memory allocations, variables get allocated only if your program unit gets active. Okay, the variables which are present in the which you have written for your dynamic memory allocation, those will be getting allocated only when that particular statement or that particular block of code is active in your memory. Okay, so that particular block of code is active in the execution. Only during the execution the memory will be present. Once after the execution, the memory will be reallocated or released. Okay. The third point, it uses the data structure called as stack for implementing static allocation. As I told you, your local variables, those are the static memory allocation. Okay, that will be coming from the stack. The local variables data memory will be coming from the stack, and your dynamic memory allocation will be coming from heap. Okay, it uses the data structure called heap for implementing the dynamic allocation. So the dynamic allocation will be implemented by using a data structure called as heap, and the dynamic allocation for your static allocation for your local variables will be done by using a data structure called as stack. It is less efficient, it is more efficient. Why it is less efficient? Because the static memory allocation, the memory allocation will be done during the compilation, and it is a permanent memory. During the execution of the program, if you want more number of elements in your program, for example, if I have declared a 10 elements array, okay, if I have declared while during the application development, you have declared you have declared an array with 10 elements. During the execution of your same application in the production environment, if your array needs more number of elements to execute, that is, if more number of elements are coming into the particular array at that time, so that if you are having more entries to operate upon, your particular thing has only 10 memory allocations to operate on. So you cannot assign or you cannot increase the size of the memory while on the go, that is during the execution. So this static memory allocation can be done during the development time when the developer is implementing the code. The dynamic memory allocation can be done during the execution of the program, that is when the particular application is actually in use at the customer side. So when your particular application is in use at the customer side, you cannot modify whatever the code that is written inside. Okay, so the number of elements which you are having in your particular program will be fixed in a static memory allocation. Okay, so you cannot keep changing that. If more number of elements come into your program, you cannot change the size of the memory. Okay, it is not possible and it is not efficient to implement a particular program in static memory allocation. Okay, it is more efficient if you implement something in a dynamic memory allocation. Why? Because you can allocate some certain part of the memory for a certain variables, and if it is in not use, you can deallocate that memory. That is, you will be having a set of memory. That particular memory will be fixed here, fixed and permanent. You cannot reuse this memory. But here, if you see the dynamic memory allocation, it is not a permanent memory. It can be allocated and deallocated. So the same memory can be used for multiple purposes based upon your application. You can increase the size of your memory. You can allocate more number of elements based upon your application's request. Okay, so this will be more efficient while implementing your memory allocation. There is no memory reusability. As I told you, whatever the memory which you assign for your variables will be a fixed part. There will be no reusability in any way. But here there is a memory reusability as why? Because in dynamic memory allocation you can allocate as well as deallocate the memory and reuse the same memory for different purposes during the execution of your program. So this is the advantage of your dynamic memory allocation. In the dynamic memory allocation, as you can remember, the dynamic memory allocation will be done during the execution of the program, okay, and it will be implemented by a heap, and it is more efficient. Why? Because you can reuse your memory. So these are the advantages of your dynamic memory allocation. You should be able to differentiate between your static memory allocation and dynamic memory allocation. So this is about your memory allocation. The dynamic memory allocation in your C language, okay, will be performed by using certain set of functions. So the process of allocating memory at runtime is known as your dynamic memory allocation. Library routines known as memory management functions or dynamic memory allocation functions. Memory management functions or dynamic memory allocation functions are used for allocating and freeing memory during the execution of your program. So your C language will provide a certain set of dynamic memory functions which can be used to allocate and deallocate memory from your heap. So these functions are present in standard library header file, that is stdlib.h header file. So during usage of any of the dynamic memory allocation function, you have to include this standard library header file. So what are the various functions which you have as a part of your dynamic memory allocation which are present in stdlib or standard library header file? So we are having malloc, we are having two memory allocation functions, malloc and calloc. This is memory allocation. This is cascading memory allocation. This is memory allocation. This is cascading memory allocation. So the memory allocation will provide you, so based upon the number of bytes you specify, those many number of bytes will be will be released, and those many number of bytes will be allocated for your memory. Okay. So allocates requested size of bytes and returns a void pointer. Okay, remember it will return a void pointer pointing to the first byte of your allocated space. Okay, it will return a void pointer pointing to the first byte of your allocated space. What it means if I perform malloc of 50, what that means it will allocate 50 bytes of memory, that is one block of 50 bytes of memory, okay, where the first byte will be present, and this first byte will be having one void pointer. That is, one void pointer will be pointing to the first allocation. In the discussion of your pointers, I told you will be having void pointers. These void pointers can be used to point to any point. Okay, that void pointer can be used to point to any pointer. If you are having an integer pointer, it can point to only an integer value. So if you are having a floating point pointer, it can point to only a floating point value. But if you are having a void pointer, it can be used to point to any value. So now, since you doesn't know what you want to implement, that is whether you want to store integers in that particular values in this memory, or you want to store floating point values in that memory, or any other values in that memory. So since you doesn't know, what you can do is, you will be having a void pointer pointing to that particular memory. So in a memory allocation or malloc, it will return the size of bytes which you have specified in this particular parameter. Those many number of bytes will be returned from the memory, and it will return a void pointer pointing to that first memory location. If there is no allocated space, that is, if there is no 50 bytes in your heap, at that time it will return null. That is, it specifies that there is no memory present, that is, that much amount of memory is not present in your particular heap. Okay. So either it will return a void pointer. Void pointer will point to the first byte of the allocated space, or it will return a null. Null means there is no memory for you to use. Cascading allocation or calloc allocates space for an array of elements. Okay. Usually calloc will be used for the same memory allocation, but this will be used for some structures and arrays. Okay. Usually calloc will be used for some derived data types like your arrays, structures and other data types. So calloc also will be returning some memory. Allocate space for an array of elements, initialize them to 0 and returns a void pointer pointing to the memory. Okay, so we'll be looking at the examples of calloc and malloc and see the difference between calloc and malloc. And free is for deallocating the memory. So if one of the memory allocation is not in use, you can deallocate that memory. So it releases previously allocated memory. The free function will be used to release the previously allocated memory. And the last one is reallocation. Okay, if you have done allocation by using your malloc and calloc, and at any point of the program, if that particular allocation is not sufficient, you can reallocate the memory by using realloc. Okay, so remember these are the four functions. That is, one is malloc, which will malloc and calloc will provide the memory. Free will be used to release that memory, and realloc will be used to reallocate the existing memory. So we'll be looking about these particular types of memories. The first one is the malloc function, which is used for allocating block of memory at the runtime. If this function reserves a block of memory of the given size and returns a pointer of void type. This means that we can assign it to any type of pointer using typecasting. So what is the meaning of the last point is, so if your malloc function will be in this manner, as I told you. Okay, you have to specify the size of number of bytes you want to have for the dynamic memory. Okay, so we will be getting 50 bytes of memory. 50 bytes. So when I get 50 bytes, it will return a void pointer which is pointing to the first memory location. Okay, so since this is a void pointer, I can use this 50 bytes to point to any data type. If I want to point to an integer data type, I have to typecast it to integer. Okay, if I want to use this for 50 bytes for storing characters, I will be typecasting it to characters. If I want to store this particular number of bytes for storing float values, I will be typecasting it to float values. How you are going to typecast? Typecasting means if I want it to store for integers. Okay, if I want to store this particular memory for integers, then I will write int star. This is typecasting of your integer. Malloc your 50 bytes. Okay, you need not write this thing. Okay, you need not write that particular thing. So how you are going to write? Int star. This is the typecast. Malloc 50. Malloc 50. So it will be returning 50 bytes, and it will be a void pointer return. That void pointer will be converted into an integer pointer. Okay, so we are typecasting that void pointer into an integer pointer. Now the 50 bytes allocated will be pointing to an integer pointer. So you can use the integer pointer and store the integers, and you can move in your dynamic memory one by one by using your pointer arithmetic. That is, you can increment your pointer and go to the next memory location which is pointing to the next integer. So this is how your dynamic memory will work. That is how your malloc function will work. If you see how this will work, if the allocation fails to provide enough amount of space, it will return a null pointer. So if there is no allocation and if there is no memory, it will return a null pointer. The basic syntax of your malloc will be in this manner. That is, malloc, the byte size, that is, if I want 50 bytes, I will specify 50. Okay, and it will return a void pointer. So in the program, you can use the same thing here. First you need, if your particular program is used for integers, okay, so that is, I am trying to allocate memory for your integers. What I need to do is, I am specifying, I am first creating an integer pointer x. I am creating an integer pointer x. Then what I am doing? So I am malloc 50, that is those many number of integers I want to store, 50 into size of int. That is, size of int means if the system has 4 bytes integer, it will take 4. 50 into 4, 200 bytes of memory block will be created. That is, a 200 bytes of memory block will be created. Since I am using this particular program for integers, that is why I am using size of int. Size of int means 4. 4 into how many integers I want to store? 50. 50 into 4, 200 bytes of memory will be assigned, and it will be returning a void pointer, and that particular void pointer will be converted or typecasted into integer pointer. That integer pointer will be now assigned to x. So now x will be pointing to the first byte in the memory assigned. So this is how your dynamic memory allocation will be done by using your malloc function. Once after using this particular allocation, that is, now your x will be pointing to the first memory location or the first integer. If I perform x++, that is your pointer incrementation, which you have seen in your pointer arithmetic. If I increment the pointer, it will point to the next integer present in your memory or the next memory location. Okay. If you increment your pointer, it will go to the next possible integer memory. So in that manner, you can go to all the 200 bytes of memory. Okay, from the starting to ending bytes. Once after using this memory, if I want to release the memory, I can use free of x. If I use free of x, now this pointer will be deleted and this memory will be released. Okay, so this is how your dynamic memory allocation will be done by using malloc. The same case, C allocation will be used for memory allocation, for allocating memory at the runtime. This is also a memory allocation function, and this will be done for allocating memory to derived data types like your arrays and structures. If I want to allocate memory for your arrays and structures, we will be usually using calloc. So if it fails, it will return a null pointer. So this is an example of your first you are showing the syntax. First you are showing the syntax, that is void calloc number of items and the element size. In the previous, if you see, you are having malloc directly element size. Okay. So if I want 50 integers, how I am specifying? 50 into size of int. Okay, if I want 50 integers memory, I am specifying 50 into size of int. But in calloc, I will specify the number of items I want first, that is 50 elements. Then I specify the element size. What is the element size? That is, I want the element size of an integer. That is, I want 4 bytes element size. Okay, what is the difference between your malloc and calloc is, in malloc, we will be getting a 200 bytes block. In calloc, we will be getting 50 4 bytes blocks. We will be getting 54 bytes memory blocks. Here we will be getting 50 into 4, 200 bytes, and they will be present in a single block. In cascading allocation, that is, they will be present cascadingly. So we will be getting 50 blocks of 4 bytes each. So that is how your cascading allocation will happen. Usually it will be used for allocating memory for your arrays and structures. Okay. So if you see this example where you are creating a structure employee, okay, employee is having two values, one is name and another one is salary. So I am type defing that to EMP. Now the employee structure is renamed with EMP. What I am doing is I am creating a pointer to EMP. So I am allocating calloc 30 elements, that is, I want 30 structure employees, that is 30 employee objects memory, size of EMP, that is whatever is the size of this particular structure, that particular size will be taken here. Okay, so you will be having 4 bytes and 1 whatever will be the name of your particular structure. So this will be a variable thing, that is the name of your character will be a variable thing, and this is a salary. So based upon the size of your employee object, that employee object size will be taken here, and you will be providing memory for 30 elements of structures, that is 30 employees memory will be allocated, and 30 employees memory will be allocated. And when you perform the calloc also, we will be getting a void pointer. That void pointer has to be typecasted into this employee structure. Why? Because whatever the memory that is assigned by your calloc has to be used for employee structure. In the previous example, whatever the memory you have assigned or allocated, we have used for integer. That is why we have specified integer typecast there. Here we are using that memory for your employee structure. That is why I am performing employee typecast. Okay, this is how your calloc will happen. Your malloc and calloc will be used for dynamic memory allocation of your memory, and you are having the free which is used to release the memory which is allocated by malloc or calloc. What is the differentiation between malloc and calloc? Both will be used for memory allocation. The first difference is your calloc initializes the memory with 0 value. Okay, so whatever the allocation which it does, all the elements will be initialized with 0. But your malloc doesn't initialize it to 0, it will be containing garbage values. Next one, the number of arguments is 2 in your calloc. In calloc, you have to specify the number of elements followed by the size of the element. But here, you have to specify only the size of memory you want. The number of arguments will be only 1 in your malloc function. Here you have to specify 2 arguments. One is the number of elements, the second one is the size of memory. Here you have to specify 1 argument, that is the total amount of memory you want. Third one, as you could see, the syntax calloc, blocks and the size of the block. Okay, malloc, size in bytes. As I told you, you will be getting those many number of blocks with the size. Here you will be getting a complete single block. So this is the differentiation between your malloc and calloc. And the last one is reallocation. Reallocation will be used to change memory size that is already allocated dynamically to a variable. Okay, you have already done memory allocation by using either malloc or calloc. If you want to reallocate that memory, you can be using the realloc function. So the realloc function will be having this syntax, that is where you will be having void pointer, reallocation, the previously used pointer, that is where you have done the memory allocation, that pointer, and the new size. What is the new size you want? For example, so you are having an integer pointer and you have done malloc 50 into size of int, that is you have done 200 bytes of memory here, but those 200 bytes of memory is not sufficient. Now what you can do is, you can reallocate x, 100. Now you can reallocate that 200 bytes to 100 bytes, or you can reallocate the 200 bytes through 300 bytes also. So you can reduce the memory or you can increase the size of that particular memory. So reallocation can be done for already existing allocated memory. These are the dynamic memory allocation functions which you can use to implement your dynamic memory allocation in C language. You will be using malloc and calloc to allocate memory, reallocation to reallocate memory, free to release that particular memory. So in this session you should have known the advantage of your dynamic memory allocation and how you can perform dynamic memory allocation in your C language by using the dynamic memory allocation functions. In the next session we will be going for a new topic. Thank you.